Welcome to AB Academy. Alright, today we are gonna unpack one of the most powerful and honestly coolest tools in all of modern science. High-performance liquid chromatography. Now know the name HPLC sounds super complex, but what it does is actually fascinating and it affects our lives literally every single day. So, let's just start with a really high-stakes question. Imagine you are a scientist who's just developed a new life-saving medicine. How can you be 100% sure that what's inside that pill is exactly what you think it is with absolutely no dangerous impurities? I mean, when people's lives are on the line, you have to be certain. Well, the answer to that huge question. It all comes down to the science of separation. The ability to take a really complex mixture and sort out every single little thing inside it, right down to the molecular level. To really get what makes HPLC so special, we first need to look at the basic idea it's built on. It's a brilliantly simple concept called chromatography. So what is it? Put simply, chromatography is the art of sorting molecules. It's a method that lets scientists take a jumbled up mess of different substances and just meticulously untangle them. And here is my absolute favorite analogy for how this works. Imagine your mixture is like a family walking through a crowded space, and that space is a candy store. The kids, right? They're gonna get distracted by all the candy. They will slow down, stop and look. But the parents, they are on a mission, they just keep moving. And right there, that difference in speed, that's what causes the separation. And this is exactly what that looks like. In a simple lab setup, you pour the whole mixture in at the top. As it flows down through that tube, it starts to separate into these distinct color bands. Each band is a different group of molecules, our parents and children all moving at their own unique speed. Now that basic idea is fantastic, but let's be honest, it's pretty slow. So how do we get from that simple glass tube to the high-tech powerhouse we have today? Well, it was all about adding some serious speed and power. You know, this whole journey took about 100 years. It starts with a botanist just trying to separate the colors in plant leaves. But the real game changer happened when scientists figured out how to make the packing material inside the column. The candy, unbelievably tiny. The smaller the particles, the better the separation. But there was a catch. It became almost impossible to push the liquid through. And that's the big upgrade. We went from the old way, a slow process, just using gravity with pretty big particles, to brand new system, one that uses incredibly powerful pumps to force liquid at super high pressure through columns packed with microscopic particles. The result, a separation that is lightning fast and ridiculously precise. And here's a cool little bit of history for ya. At first, they actually called it high-pressure liquid chromatography, which makes sense, right? But as every part of the system got better, the pumps, the columns, the detectors, the realized pressure didn't really capture it. So they changed the name to high performance because that's what it had truly become. Okay, so now let's pop the hood. The machine itself can look like this big, imitating box of science. But I promise, once you see what inside, it's really just a few key parts working together perfectly. Okay, here's the whole shebang. It all starts with the liquid, which scientists call the mobile phase. Because, well, it moves. A pump shoves it toward an injector, and that's where our sample get introduced. From there, the mix with the column. That's where the magic happens. And finally, our detector reads the results. So let's walk through that step by step. First, the pump. This is the engine of the entire system. Its only job is to push that mobile phase through everything else with incredible constant force. That relentless high pressure is what put the high performance in HPLC. Next in line is the injector. This is the starting gate. It's where our sample, the thing we actually want to analyze, gets introduced into that fast-flowing stream of liquid. And it has to do it with pinpoint accuracy to make sure the race starts cleanly. And now we get to the absolute heart of it all. The column. This is our candy store. It's a tube that's tightly packed with a material called the stationary phase. Because it doesn't move, this is the stuff that our sample molecules will interact with. This is where that separation actually happens. And finally, as each perfectly separated group of molecules exists the column, it flows through a detector. Think of it like a high-tech camera at finish line. It sees each molecule as it across, identifies it, and counts how much of it there is. All that data then gets zapped to a computer, turning these invisible molecules into a graph we can actually read and understand. So, okay, we have these incredible machine that can sort molecules. Big deal, right? Well, yeah, it is a huge deal. Let's bring this all the way back to why these technology really matters in the real world. This number right here just says it all. Over a third, 35% of all HPLC systems in the world are used to make medicines. It is the absolute gold standard for making sure the drugs we rely on are pure, powerful, and safe. And its reach goes so far beyond just medicine. From checking our food and drinks for pesticides, to cutting-edge research in life sciences, to crime scene forensics, and even monitoring pollution in our environment, HPLC is absolutely critical. So here's the real takeaway. Think about its impact on your day. Every time a new drug is created, every time a batch of food is checked to make sure it's safe to eat, every time a forensic lab analyzes a tiny piece of evidence, there is a very, very good chance an HPLC machine is in the background doing that essential job of separation. It's really incredible when you think about it. What started with a curious botanist just trying to separate the colors in a leaf has now become this indispensable technology. It literally lets us see the invisible building blocks of the world all around us. That just leaves us with this one massive question. Now that we have this incredible power to take anything apart and see what it's made of, what huge mysteries are we gonna solve next simply by separating the pieces? Thanks for watching. Hope you liked this video. Comment on which topic you would like to see a video on.